Option C, kinetic to light to heat to electricity. Then option D, electricity to kinetic to heat, then to light. So what is the energy conversion that happens? They say, which of the following best describes the energy changes which takes place when a steam engine drives a generator which lights a lamp? So what energy changes occurs? D, like this one, okay, heat to what? Kinetic energy, then kinetic energy to what? Electrical energy, then from electrical to heat and what? Light. That is the answer. That is the answer. Only sometimes. Sometimes. Next question. Cathode rays are A, high energy electromagnetic waves. B, protons. C, neutrons. D, streams of electrons. Streams of electrons, yes. Streams of electrons. Next question. A narrow beam of white light can be split up into different colors by a glass prism. The correct explanation is that A, white light is an electromagnetic wave. B, prism has all the colors of the white light. C, different colors of white light travel with different speeds in glass. Is that the answer? Okay, next question. Next question. Okay, next question. There is a pulley system. There's a pulley system there. I'm not going to draw it beautifully. We are going to manage anything I draw. Okay, this is basically the pulley system and all that. Okay, and then they gave, I think, W Newton here. W Newton. And then 200 Newton. This is 200 Newton, please. Sorry, 120, not 200. Okay, they now asked, the figure represents a block and tackle system, pulley system, on which effort W Newton, so W is the effort, supports a load of 120 Newton. If the efficiency of the machine is 40%, what is the value of W? Is it solvable? Oh yeah, let's tell them. We tell them that efficiency is what? Mechanical advantage over velocity ratio times 100 over 1. What is the efficiency from the question? 40. MA we don't know. Where? Over VR is how many? 6. How do we know it's 6? Number of pulleys. Where? So we have 6 here times 100 over 1. Okay. 2 here 3. 2 here how many? 50. So we can say that 3 times 40 is what? 120 is equal to 50 MA. Are so that MA is 120 over 50. This takes this. 12 over 5 is how many? 2 point what? 2.4. So if I know MA, I will go back and say MA is equal to load over what? So that 2.4 is equal to load is 120. Then effort is W. Effort is W. So that W becomes 120 over 2.4. What is she, please? 50. So 50 Newton. 50 Newton. That is option D here. That is option D. Okay, next question, number 11. What type of reaction is represented by the following scheme? Okay, we have okay. Energy that is there. Okay? They said, what type of reaction is represented by the following scheme? Option A, fusion reaction. B, fission reaction. C, chain reaction. D, radioactive decay. What's the answer? Is it fusion reaction? Did you say fusion or fission? That is FU, right? What is the meaning of fusion? Joining of two smaller nuclei to form heavier one, right? What about fission? Splitting, breaking down. Good. So how do we know that this is a fusion reaction? If you notice, these two combined and they formed an element with this. And then, of course, you know when you balance the nuclear reaction, everything is balanced here, right? And when you also balance this, is also balanced, plus the release of energy. Okay, so this is a nuclear fusion process. Okay, number 12. The amount of heat needed to raise the temperature of 10 kg of copper by 1 kg is its what? A, specific heat capacity. B, latent heat. C, heat capacity. D, internal energy. Answer is what? Heat capacity. Why is it not specific? Because it is not 1 kg. Remember, specific means that it is what? 1 kg. But in the question, they said how many kg? 10. They said 10 kg. So the answer is heat capacity. Okay, next question. The electrochemical equivalent of silver is 0.0012 gram per coulomb. Electrochemical equivalent of silver is 0.0012 gram per coulomb. If 36 gram of silver is to be deposited by electrolysis on the surface by passing a steady current for 5 minutes, the current must be, now we are going to use Faraday's law there, right? Faraday's law. And from Faraday's law, what formula do we generate from there? MO is equal to what? ZIT. Where? We are looking for current. I becomes what? M over ZT. Where? Good. So we check for the mass given. The mass given was 36 grams. So I have 36 divided by 0.0012 times time. They said time is 5 minutes. So 5 minutes, I multiply by 60, right? Okay, so 36 over what, please? Multiply this. 0.0012 times 5 times 60. 0.36. And when I divide, what do I get? I get 100 what? Amps. 100 ampere. That is option B here. Okay, next question. Shadows and eclipse result from what? A, refraction of light. B, reflection of light. C, diffraction of light. D, rectilinear propagation of light. 15. Which of the following obeys Ohm's law? A, all metals. B, diode only. C, all electrolytes. D, glass. Answer is what? All metals. All metals. Good. You know diode is a semiconductor, right? So it doesn't obey Ohm's law. In JAMB, you can see it as which of the following are non-ohmic. So if you hear non-ohmic, what does that mean? They don't obey Ohm's law. An example is a diode, transistor, gases, electrolytes, and all that. Because if you look at the statement of Ohm's law, he says that the current through a what? Metallic conductor. Metallic. So that statement there is very important. Let's continue. Which of the following statements are true of isotopes? Which of the following statements are true of isotopes? I. Isotopes of an element have the same chemical properties because they have the same number of electrons. B. Sorry, I. Isotopes of elements are normally separated using physical properties. I. Isotopes of an element have the same number of protons in their nuclei. So which one is the answer? I and I. Good. Okay, let's continue. Number 17. Number 17. Number 17. We have a diagram looking very weird. Okay, so we have a mass M1 here. And we have it attached to a pulley. And the other mass is attached here. This is M2. This is M2. Okay, they now said in the diagram above, the hanging mass M2 is adjusted until M1 is on the verge of sliding. The coefficient of static friction between the mass M1 and the table is what? Option A, M1 over M2. Option B, M1G over M2. Option C, M2 over M1. Option D, M2G over M1. Eh? Keko shibulu si. Akwe kram go past question. Eh? Akwe kram go past question. Okay. So let's get. Have you refilled the marker? Okay, so let's get the answer together. Now, class, first of all, to analyze this, I need to establish the tensions. Tensions are the forces acting on the strings. Okay? Anytime you attach something to a string or a rope, tensional force exists on that thing. For example, you have pictures in your house that you use rope to hang. On those ropes, you have tensional force. Okay? So anytime you hang anything on a rope, that thing is creating a tensional force. So it's work on Sunday. It's work on Sunday. The reason why that rope will now bend like this is because there is a tensional force now on that rope because of the cloth you spread on it. Are you with me now? Good. So because this mass was attached to a rope, there will be a tensional force. Call it T. Here also T. So T and T are the tensional forces. Now, class, this guy that is hanging here, you see that if you leave this system, let's assume that the system is going down this way, accelerating down. Please, I need like blacker marker. I don't like seeing shadow. Now, so if this mass was going down, you see that the weight of this guy will be acting downwards. Class, what is the formula for weight? W, mg. Are mass times acceleration due to gravity. So the weight of this guy will be m2g. Dragging it down. That is M times G. Is there any other one that you refute? Okay, so the weight is M2G, dragging it down. Now, because we have a force acting down and we have a force acting up in this system here, we need to find resultant. When two things are dragging in opposite direction, resultant is the subtraction of both of them. Resultant is what now? Subtraction of both of them. It's just like when you are doing tug of war. People are pushing from this side in this direction. Others are pushing from this side in this direction. So the resultant force is the other one minus the other one. Meaning that that whole game, the person that will win is who is exerting more force. Or is Yoku now? Good. So the resultant force here is M2G minus T, that is this downward force, minus the upward force. And this will be equal to mass times acceleration, because we know that force is MA. Are we now? So A is that our acceleration. But which mass are we talking about? M2. So this is M2. So mg2 minus T equals M2A. Call this equation again 1. Call it equation 1. Then let's come to the other side. Let's come to the other side, which is the tabletop. Remember, they are asking us for the coefficient of friction, meaning that this table has friction. And from what you know about friction, friction opposes what? So if this thing is trying to go like this, friction says you are not going anywhere, you are going back. So Fr, which is frictional force, is mu mg. Akweziyoku now. And which m will it be? M1. So this is M1G. So let's continue. So what is the resultant force here? This guy dragging this way. This guy dragging this way. So the resultant force will be what? T minus mu m1g. That is the frictional force going this way. This minus this. And this is still equal to mass times acceleration. Which mass? m1. m1. So this is equation 2. Then I add both of them together. I say equation 1 plus equation 2. By the time, why am I adding? So that t and t can cancel out. If they cancel out, I'm left with what? m2g minus what? Mu m1g equal to m2a minus what? m1a. That is what I will have. m1a. That is what I will have. Okay? Now, but if you go back to the instruction of that question, they said when it is at the verge of sliding. When it is at the verge of sliding, what does it mean to be at the verge of sliding? That means you still want to start. You have not started sliding. You still want to start. Now, at that point where the object wants to start, acceleration is still what? 0. It has not started moving. So A is 0. Now, open and A is 0. By the time we put A here and A here, everything here becomes 0. Are we here now? So that you are left with m2g minus mu m1g equal to 0. Move this guy over. We have m2g equals mu m1g. Then we make mu the subject of the formula. And the mu becomes m2g over m1g. Can g cancel g? And we have m2 over again now, m1. That is how we got the answer as C. Okay? It appears long, right? So that means that JAMB wants you to know how to analyze something like this. If you see it. But don't worry, you will not see anything that will give you headache. Which of the following may be used? Another question. Which of the following may be used to explain a mirage? Which of the following may be used to explain a mirage? I. Layers of air near the road surface have varying refractive indices in hot weather. II. Road surfaces sometimes become good reflectors in hot weather. C. Light from the sky can be reflected upwards after coming close to the road surface. So which one can be used to explain mirage? I says layers of air near the road surface have varying refractive indices in hot weather. Is that one among? Yes, it is among. Go. II. Road surfaces sometimes become good reflectors in hot weather. No. III. Light from the sky can be reflected upwards after coming close to the road surface. Yes. So answer is I and what? I. Only. Only. Next question. Next question. Okay. They said in the diagram above, if the atmospheric pressure is 760 millimeter mercury, 760 millimeter mercury, what is the pressure in the chamber? G. Here is 10 cm. What is the pressure in the chamber? G. I tell them that the pressure at G is equal to atmospheric pressure plus height difference. Plus what now? Plus height difference. So in our class, height difference means from eba kita to eba. Class, this is our height difference. If you look at this, agwa from eba to eba about 10, and from eba to eba about 3. What do you think from here to here should be? So H should be 10 minus 3, which is how many? 7 cm. So we'll say 760 plus, be careful. This guy is in centimeter. Are you with me now? This is in centimeter, but the atmospheric pressure is in what? Millimeter. So you must convert this guy to millimeter before adding. How many millimeter make 1 centimeter? 10. So multiply by 10. That will be 70. Are we here now? We add, and that gives us 8 what? 830. 830 millimeter mercury. So be very careful with that question. So because in the option you might see 767, and you just jump and pick 767. And then when you now come out, somebody will tell you it's not 767. Be like, hey, please don't do that. Don't lose careless 2.5 marks. What did I say? What did I say? Don't lose careless 2.5 marks. 2.5 marks. You know each mark is 2.5, right? So don't go and carelessly lose it. Don't carelessly lose it. Because my spirit will not be happy with you. Yes. My spirit will not be happy. Okay, next query. Which of the following has the lowest internal resistance when new? Which of the following has the lowest internal resistance when new? Option A, Leclanche cell. B, Daniel cell. C, touch battery. D, accumulator. What is the answer? Accumulators. Yes, accumulators. Accumulators. Class, how many types of cell do you have? 2. What and what? Primary cell and what? Secondary cell. Which ones are primary cells? What are primary cells? They are cells that you cannot reverse the chemical reactions going on within them. Or simply, they are cells that cannot be recharged. Cells that cannot be what? Cells that cannot be recharged. Oh, my, that is what it means. Any cell you cannot recharge is a primary cell. Example, the one in your remote. Is it when it dies, you go and charge it? You throw it away, shey, and buy a new one. The one in your phone, do you recharge it or not? You recharge it. So is it primary cell? It will be what? Secondary cell. Because it is rechargeable. You can reverse the chemical reactions going on within it. Car battery beacon, is it primary or secondary? It is secondary cell. Okay? It is secondary cell. Okay? So, and examples. Now, in this particular option, the answers were just straight to the point. If I remove that accumulator and put lead acid battery, you might go and choose something else. But lead acid battery is a secondary what? Cell. Are you with me? Just like you know that Daniel cell, is it primary or secondary? Primary. Leclanche cell, primary. Okay. The pitch of an acoustic device can be increased by what? A, decreasing the loudness. B, increasing the amplitude. C, increasing the frequency. D, decreasing the intensity. Remember, pitch depends on what? Loudness depends on what? What about quality? Overtones and what? Harmonics. Class, the sound from different instruments can be distinguished owing to their difference in quality. Owing to their difference in quality. Now, a note which is 1 octave higher than 225 hertz is... You are still looking at me? Don't worry. Don't worry. Don't worry. Let's continue. Wait, you don't give me the answer? You don't know? We did not do, I did not tell you anything about octave. I did not tell you anything about octave. I did did not tell you anything about octave. Hey. 400. 400 bao. Bao ni 400. Auntie? Bao she re 400. I told you that the frequency 1 octave higher means twice that frequency. Twice that frequency. And I'm now gulunya ke that day. So I said, I now asked you, what is the frequency that is 1 octave higher than 225 Hz? Oshemu 400. Eh? I said 225. It's not me you who embarrass you. Another question. Which of the features of the fission process? Sorry, one of the features of the fission process is that A, it leads to chain reaction. B, its products are not radioactive. C, neutrons are not released. D, the sum of the masses of the reactants equals sum of the masses of the products. One of the features of the fission process is that it leads to what? Chain reaction. Do you know what chain reaction is? Do you know what a chain reaction is? You can't pass question, Shay. I say yes. Say the truth. You can't pass question, right? So I don't say no. What is chain reaction? Chain reaction. What is a chain reaction? Okay. Yeah, you tried. Now, when you say a chain reaction is a what? You can say it is a stream of successive reactions where each step or phase depends on the previous. As simple as that. A series of successive what? Reactions where each phase depends on the previous one. So, in that nuclear process where we say something like chain reaction, what happens is that if you start a nuclear fission process by bombarding uranium-235 with, let's say, a neutron, that single neutron will bombard that that uranium and produce 3 neutrons. The 3 neutrons will now go back into the chamber and bombard that uranium and produce 9. So the 3 will produce 9, each of them producing 3. The 9 will go back and produce 27. The 27 will go back and produce how many? 81. The 81 will go back and produce 81 times 3. Okay? Then that 81 times 3 will go back and produce 81 times 3 times 3. And so on. So within few seconds, the whole chamber will be saturated. The whole chamber will be what now? Saturated with neutrons. That is why, Jam, again, we ask you that in nuclear reactors, what is added to slow down the movement of the neutrons? Have you seen that question before? Yes, so what do they normally use to slow down or absorb the neutrons? First of all, absorbing is different from slowing down. Slowing down is different from absorbing. They are two different things. So what do we use to line the walls of that wall in order to absorb the neutrons? How do you use to slow them down? Okay. So to absorb the neutrons, they line the walls with graphite, with Guinea class. Get to now. Did I say that absorbing is the same as slowing down? they are different. To absorb means that as they are coming out, something is collecting them so that they will not go and react. Because if you leave it, let's say we get to a number like 1 million. If you leave that 1 million, they will go back and produce times 3. So, in order for us to slow down the reaction, we have to absorb some of them. So, the walls of that chamber is lined with graphite to absorb them. Then, JAMB will ask you, how do you now slow them? Because they are very fast too. You might be planning to absorb them. They have already done what they want to do. So we also need to slow them down. Slow them down. So we use boron rods. So slowing down is boron rods. Then absorbing is what? Graphite. Now, another important question is they will ask you what is used as the coolant. Because the reactor normally gets very hot too. Like Odirokwana Agwagi is the kind of hotness of the sun. That is the kind of hotness. Like Eban will be like very, very red. If they don't control the process, it might just explode. And the kind of explosion will take an entire city down. So people working there must always find a way to cool the reactor. Come on, in fact, they cannot say, let's go and on it while you bring the coolant. No. If once you on it, the temperature will go from like 0 to 1,000,000 degrees Celsius. Like sharp, sharp. So they have to always control that process. So what coolant do they make use of? They don't make use of water. Oh, if JAMB asks you that question, they will put water in the option. And your head will tell you water. Because all water keja abanyoku akwezi yoku. Ore yawa. Ora mmiri keja abanyoku. Oh mmiri. But the answer is not water. Why is it not water? Because if you put water, water produces more neutrons. Water has plenty neutrons inside. So if you pour water, water will produce more neutrons, and the process, instead of, have you ever seen a situation where you are trying to off fire and the water is like fuel? That's the same thing that will happen there. The water will just be like fuel and the whole temperature will continue to increase. So instead, they use, is it liquid sodium or sodium vapor or something like that? Okay? Either, I think it's, confirm that, either of the two. It is either liquid sodium or vapor, sodium vapor, something like that. Someone should just confirm that for us. I don't know if it's the liquid or the vapor. Confirm that, confirm that. You can just say the coolant used in nuclear reactors. Coolants used in nuclear reactors. Or you ask if sodium vapor, sodium whatever is used in nuclear, so that we can get that information correct. Okay, let's continue. As we wait for someone to give us the answer. Yes? Liquid, okay, liquid gain sodium. Liquid sodium, take notes. Liquid sodium. Okay, number 23. The linear expansivity of brass. The linear expansivity of brass. I can't see this clearly. Does anybody have this past question again? Okay, they said the linear expansivity is what? What's the value? Okay, 2 times 10 power minus 5. So they said the linear expansivity of brass, so alpha, you said 2 point what? 2 point what? 2 times 10, okay? Raised to power what? Minus 5 per Kelvin, okay? So that is the linear expansivity of brass. And then I said, if the volume of the piece of brass is 15 cm cubed, so V1 is 15 cm cubed. At what temperature is that, please? At 0, okay? So theta 1 is 0 degrees. What is the next thing? What is the volume at 100 degrees here? Where? Is it 100? So theta 2 is 100 degrees C. And we are looking for V2. V2 is unknown. Now, class, I will tell them that volume expansivity is V2 minus V1 over V1 theta 2 minus theta 1. Have you seen this before? Good. Now, but you know that this is volume expansivity. They did not give it to us. What they gave us was linear expansivity. So how do we convert that linear to volume? 3. So times 3, Akuya. So if I multiply this guy by 3, what will I have? 6 times 10 power minus 5. Deal? Good. Equal to V2 is what I'm looking for, minus 15 over V1 is 15. Change in temperature is what? Is it 100? Because 100 minus 0 is 100. Or you cross multiply for me. Please get me an answer, sharp, sharp. V2 minus 15 is equal to what? 6 times 10 power minus 5 times 15 times 100. 0.09. Then move over. V2 becomes 0.09 plus 15. And that will give us 15.09 cm cubed. 15.09 cm cubed. Okay, let's move on. A lead bullet of mass 0.5 kg. Now, class, let me ask you, why is it that lead pipes are not used in making pipes? Lead is not used for making pipes that is used to supply water, like drinking water. Eh? Now, give me. Eh? Is it soft or what? Is it hard or soft water? Which one do you know? Oh yeah, why is he not used? Leading to lead poison. Okay. So for your mind, they might. Okay, they said a lead bullet of mass 0.05 kg is fired with a velocity of 200 meters per second into a lead block of mass 0.95 kg. Given that the lead block can move freely, the final kinetic energy after impact is now, all we just need to do is, first of all, let's determine the velocity after impact. If you can find the velocity, then we'll use it to find the energy, right? Okay, good. I will tell them that the momentum of gun, that is mass of gun, V of gun, is equal to the momentum of that block. Because have you ever shot a gun before? If you shoot this thing now, boom, the momentum that bullet is coming with is the same momentum that will be transferred to this thing, and this thing will move. So, mass of block, velocity of block. What is the mass of the bullet or whatever? 0.05. What velocity was it moving with? 200. That's very fast. Equal to 0.95 VB. So let's make VB the subject. This is 0.05 times 200 is how many? 10. So 10 over 0.95, what would that give me? 10.5 what? 3 meters per second. Then I will tell them that the energy is 1 over 2 mv squared. So 1 over 2 times, what is the mass of that object moving out? 0.95. So 0.95 times 10.53 squared. Are we here now? Oh yeah, sharp, help me. Help me. If they carry me, go where I don't know. Oh yeah. 52.7 joules. Okay, but the answer is not here. What is here is 150 joules, 100 joules, 50 joules, 200 joules. So let's see why we were not very close to that. Yes? What happened to the division? Okay, division. Where is it? Where? Where? Is it here? Okay. The multiplication was wrong. Okay, just say 0.5 times 0.95 times 10. This is 10.53 squared though. Is the same thing? Okay. If that is what you're getting, you use your head and be smart. Yes? Oh, yes, yes, yes. I'm so sorry. Now, listen, class, remember. Now, look at what the mistake I made. The mistake was that I am supposed to add the mass of the bullet to the total mass. Why? Because remember, the bullets penetrated that lead block. So it is the two of them that is moving together. Are you with me? So what we did was just like we were calculating the velocity which we calculated the velocity, which is okay, but we are calculating the energy of this thing. No, we are borrow energy of that bullet and whatever. So the only thing we're calculating was the energy of that block that the bullet penetrated. So, but on a normal, since the bullet has already penetrated into that block, the total mass is supposed to be both the bullet and that other guy. So please, this place has comma. So I will have 1/2 times. What is our total mass now? 0.05 times what? Sorry, plus this guy. What will it be? 1 times. What did we get as our velocity? 10.53. And when you do that, what do you get? 55 point what? 4. I even became worse. Joules. Eh? Yeah, there's supposed to be a square now. There's supposed to be a square. Which formula did they use? Yeah? M1. Let me see. M1 U1. Uh-huh. M2 U2. M1 plus M2 bracket V, right? Now, obviously this is 0. This is 0. Okay, yes. We're supposed to add this. Remember I was talking about the addition of the mass. We are even supposed to do it with the velocity side. Not only because this is where the main problem is. We are also supposed to do it here. Now, so let's do that. Let's do that. Sorry for that. You know, old age, right? Okay, so, here is correct. Nothing is changing here. But here, the bullet has penetrated that block. So the total mass is going to be 1 times VB. Okay? So that this is going to be 10 over 1, Abi, which is 10 meters per second. Then I will now apply it here. So 10 squared. 10 squared. That will be 100/2, which is what? 50 joules. Okay? But you know you are not supposed to be doing, like redoing this in jam hall. Once you get 50 something, and then 50 is in the option, you pick it. Don't go and say, let you resolve and resolve. Because that is like the time you use and solve 3 questions. I am using it on 1. Okay, let's continue. In a RLC circuit at resonance, the voltages across the resistor and inductor are 30 volts and 40 volts respectively. What is the voltage across the capacitor? What is the voltage across the capacitor? You have cramp pass question, Shay? Good. At resonance, VL is equal to VC, right? Good. Not only that, XL is also equal to what? XC. What again do you know about resonance? Is I minimum or I maximum? I is maximum, not this. Okay? Z is what? Minimum. Z is minimum. So at resonance, Z is minimum. What is the phase angle at resonance? Zero. Phase angle at resonance is 0. At resonance, the circuit is purely dash. A, resistive. B, capacitive. D, inductive. Oh, you've not heard that one before. Answer is what? Resistive. Answer is what? Resistive. Why? Because remember, phase angle is already 0. Phase angle is equal to 0. Okay? And when phase angle is 0, what does it mean? Current and voltage are in phase. Nobody's leading, nobody's what? Lagging. In a resistive circuit, should be both of them are in phase. I know when I'm talking to people and when I'm not. At this point, I know I was talking to myself. But listen, in JAMB, they might ask you, in a capacitive circuit, which of the following is true? A, voltage leads the current by 90. B, current leads the voltage by 90. C, current leads the voltage by 45. D, voltage leads the current by 45. What is the answer? Which is, say it, don't tell me B, say it. So in a capacitive circuit, who is leading? Current. Who is lagging? Voltage. Voltage is lagging. Remember that I can say leading or lagging. Shay? If I say current is leading, how can I reverse it with lagging? Voltage is what? Lagging. In inductive circuit, who is leading? Voltage. Who is lagging? In resistive circuit, who is leading? They are in what? Phase. They are in phase. If the fraction of atoms of a radioactive material left after 120 years is 1/64, what is the half-life of the material? Now, whenever they ask you about remaining fraction, please tell them that remaining fraction is equal to 1/2 power n. Remaining fraction is what now? 1/2 power n. And another thing they can ask you is about decayed fraction. Decayed fraction is 1 minus remaining fraction. So decayed is 1 minus what is remaining. So remaining fraction, according to the question, is 1/64 equals 1/2 power n. Can we change this to power 2 form? So this is 1/2 power 8 equal 6. 1/2 power n. So 2 power n is 2 power 6. N is how many? 6. Then I will use that half-life is equal to total time over n. And what we are looking for here is half-life. So T half is time. Total time is how many years? 120. So 120 years over 6, and that will give us what? 20 years. So the half-life is 20 years. Class, what is the meaning of half-life? Time taken for what? Time taken for a radioactive material to decay to half its original mass or size. Abi? In the diagram above, which of the simple pendula will resonate with P when set into oscillation? Which one will resonate with P? Is it T? Do you know why? Abi, you have crammed it. You have crammed it, eh? La cram la. Nice. Yes. You have la cram. When you now enter hall, you la smash. Abi? Abi la, you la pause, sorry. Then after exam, you now what? La smash. Now, basically, when you say resonance, resonance, what is resonance? Resonance is when one body sets another body into vibration, and both of them start vibrating at the same natural word frequency. What does that mean? Oh, my mother was on my own. On my own, JJ minding my business. And then somebody now push me. Somebody now push me. And then instead of reacting, I just mbuyankete. That one is forced vibration. That one is what now? Forced vibration. Now, but a situation where the person push me and I push the person back. The person push me, I push you back. You push me, I push you back. You push me. That kind of thing. That is what resonance is. So resonance is when one body sets another body into vibration. And then because it sets that body into vibration, both of them started vibrating at the same frequency. So they are basically asking you which one will have the same period or the same frequency as P. That is basically what they are asking you there. And the answer is T because they have the same length. Because they have the same gain now, length. Period of oscillation is 2 pi square root of L over G. Shebi? That of P it will be the same thing. That of T will also be the same because both of them have the same length. So they will resonate. Are you with me now? So know why you are answering that. Oh yeah, let's continue. The time rate of loss of heat by a body is proportional to the dash. The time rate of loss of heat by a body is proportional to the temperature of its surrounding. B, temperature of the body. C, difference in the temperature between the body and its surrounding. D, rate of the temperature of the body to that of its surrounding. Answer is what? C, difference in what? Temperature between the body and its surrounding. That is Newton's law of cooling. That is what? Newton's law. I know you've never heard of it before, right? Because the only Newton you know. Do you know that Newton actually contributed to several aspects of science? Apart from motion, the laws of motion you know. Which other Newton law do you know? Gravitation, right? What again do you know? So in this heat now, look at it in heat. So Newton came up with that idea also. Apart from that, even in what is it called, Seth? What is that thing again, Seth? I've forgotten. But there are so many other aspects that Newton contributed. That is why he is called he's like the highest scientist ever known to man. One of the highest persons. Okay? Like one of the greatest. Wouldn't you like to be remembered even when you are dead? You will now be in heaven and just be talking to somebody, or maybe Angel Michael or Angel Gabriel. You'll be like, do you know they're just calling my name right now? Okay? They're just calling my name. Okay, let's continue. A positively charged rod X. A positively charged rod X is brought near an uncharged metal sphere Y. And it is then touched by a finger with X still in place. When the finger is removed, the result is that Y has what? They said a positively charged rod X. A positively charged rod X is brought near an uncharged metal sphere Y and is then touched by a finger when X is still in place. When the finger is removed, the result is that Y does what? That is the charge on Y now, which is the metal sphere. Okay, A has no charge and zero potential. B, a positive charge and zero potential. C, a negative charge and positive potential. D, a negative charge and a negative potential. What is the answer? What is the answer? Oh yeah, listen up. Let's analyze that. Class, which method of charging is that? Now, how many ways can you create charges? You can create charges by contact, which is friction. Second one is by what? By induction. Third one is by what? You don't know? You don't know? You don't know? By prime method. Okay, now when you charge by induction, so let's bring, this is the rod, positively charged rod, and then this guy was uncharged before. So when you do this, by induction, the charges generated on the sphere, is it the same as the charge you are bringing or the opposite? It is the opposite. Okay, it is the opposite. So if I'm bringing this, now what happens is that if I bring this guy close, there will be negative charges will be closer to this side. Are you with me now? Negative charges will be closer to this side. Then positive charges will move away from that position. Am I making sense? Why are positive charges moving away? Because they are being repelled. So positive charges will move away. That is why if I now put my hand on that sphere, if I put my hand is acting like earthing. You have heard earthing before. So if I put my hand on that metal sphere, the positive charges will now follow through my hand and go down to ground. So what will be left on the metal sphere is what now? Negative. So negatives will be left on the metal sphere. That is why the answer. So negative charge, negative potential. Negative charge, negative potential. Positive charge, positive potential. Are you with me? Good. Manobu no negative can with the what you see that the ones that will go to ground is what? Negative. Then positive will remain. Did you get that? Yes. Voltage now. Potential is voltage. That is work done in moving the charge around that guy. That is the voltage. Next question. Electrical appliances in homes are normally etched so that a person touching the appliance is safe from electric shock. Eh? B, is that not the answer? Why do you etch your house? So that if you are touching that appliance, you are safe from what? Electric shock. Okay? You are safe from electric shock. As simple as that. You don't need to read any other option. Next question. The process whereby a liquid turns spontaneously into vapor is called what? Evaporation. Yes. Which of the following diagrams represent correctly a PNP transistor? Now, I want you to draw a PNP transistor for me, everybody. I'm moving around. I want to see what you would draw. Which one is a PNP transistor? Draw it for me. If you know how to draw a PNP transistor, draw it and see what it will look like. Then we will now compare and see if you got it or not. Isechego? Okay. Now, transistor has how many terminals? Aqua 3 terminals. What are the names of the terminals? Emitter, collector, and base. Abi? This is the base. Now, they said I should draw a PNP transistor. So I can say something like this. Abi? 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 Oh, you don't know? Yes, right? Then no, it's here. Is this what did they say we should draw? No, the question says NPN now. So who is Itiaku now? Me? I cannot be Itiaku now. Okay, yes. So this one is PNP. How do we know it's PNP? The base is negative. The one at the middle. Anything that is at the middle, if it is negative, the arrow is coming in. If it is positive, it is going out. That is NPN. So in the jam question, they said we should draw. They said we should choose the one that is NPN. So it means that the arrow will be pointing where? Out. The arrow will be pointing out. Okay? Out of the base. That is NPN. The differences observed in solids, liquid, and gases may be accounted for by what? A, their relative masses. B, their melting point. C, the spacing and forces acting between the molecules. D, the difference in molecules in each of them. Answer is what? C. Convex mirrors are used as driving mirrors because images formed are what? A, erect, virtual, and diminished. B, erect, real, and diminished. C, erect, virtual, and magnified. D, inverted, virtual, and diminished. So, yeni nebuno. Answer is what? A. Answer is A. musical instruments playing the same notes. Musical instruments playing the same notes can be distinguished from one another owing to the differences in their what? Eh? Huh? Adibin, I know you now. Eh? Ikoya on Zakeda Yagi smackdown. Answer is what now? Quality. Answer is quality. Please don't let any ogbanje or any demon remove that thing from your head. Okay. TUV, and you brought 2 magnets. This is south. This is another south. They now said, in the diagram above, if the south poles of 2 magnets stroke a steel bar, the polarities at T and V will respectively be what? Is it not not? Why is it not not? Because they are stroking with what? South, south. So here will be north, here will be north. But remember, north cannot exist alone, Abi. Because of what we call magnetic what? Dipole. Akuya? What is magnetic dipole? A north cannot be separated from a what? A south. So you cannot have only a north one place or only a south one place. Both of them must always be together. I told you, okay, I did not tell Med A, I told Med B. Akuya? I told Med B that the love between a north pole and a south pole is what you should be envying. God, give me that kind of love. Okay? So north and south, they love each other so much that even down to the subatomic level. Let's say you bring a bar magnet now that has north and south, and you cut it, south will still appear in the north side, and north will still appear in the south side. You cut it again, they will still appear. So even if you get the atom, the smallest magnetic atom, and you cut it, you will still have north and south, but they will still shift for each other. Honey, please appear again. Okay? So even till death cannot even do them parts. Don't you want that kind of love? Don't you want that person that will say, honey, if you are dying, I will die with you? Honey, if you die, I die with you. The world is nonsense without you. You see? Nigeria has changed your mentality. So you don't want that kind of love again. The only love you want is the one that is speaking money. The one that, honey, I want to go to Dubai to go and do some shopping or transfer. Is that what you want? So you will trade all those things for genuine love. Eh? Really? What has my generation become? Oh Lord, please come. Come. Don't tarry again. Come. Let's not write this jam, in fact. Oh Lord, come. Come on Thursday. Oh, you're not saying no. Eh? You don't know that if God comes now, you have more chances of going to heaven now than when you grow. Because some of you are you not the only reason you are still good, like you are still good, like the good self has apostrophe. The reason why you are still good, is because you are still with your parents. You have already started planning. Can we take good admission? Can we take good admission? That maybe you want to just go out and then I ask you, Chinaza, can they be in Nigeria? And I say, Mommy, can you also put Chinese? I say, back, come on, go back. And you will just be vexing. Can we take good admission? Just is good no now, poor. Ebuluzie, ego. Ebuluzie ego. Flying like ego. Eh? So it's better as you are praying, say, God, please come now that I am still good. That I am still good. Come now. Okay, don't want him to come now. Eh? Huh? Okay, you want to give birth first. You want to marry. Yes, because it cannot come to your own time and Jesus will come. Okay? I actually think like that also. That guy cannot reach my time and you now come. Please, please, I am begging. Okay? Okay, another question. In homes, electrical appliances and lamps are connected in parallel because in homes, electrical appliances and lamps are connected in parallel because A, less current will be used. B, less voltage will be used. C, parallel connection does not heat up the wire. D, series connection uses high voltage. What's the answer? Series connection uses what? High voltage. Yes, as simple as that. Okay? Series connection. If you imagine you have this house, and this house, for example, all of them connected in series. Now, the implication is that if I am NEPA people, and this house needs, let's say that all the appliance needs, let's say, 220 volts. This house, all the appliance needs 200 volts. This house, all the appliance also need 200 volts. So if I was the NEPA people, that means that the total voltage I will supply through this line is 620 volts. That's what I will supply. Okay? But if they are all in parallel, okay? If all the houses are in parallel, then if the house requirement of one house is 220 volts, of course. Now, obviously, you see that they cannot supply different voltages to homes now. They will supply the same voltage. So I will just send 220 volts. All the houses will collect it. Because they are all in what now? Parallel. So if I send only 220 volts, this guy will collect 220, 220, 220. Okay? I don't have to supply 600 and something. No. Just 220, 220, 220. Everybody will collect it once. And another implication here is that, let's say the house in the middle, their light now spoil. If their light spoil, you are also gone. No? If you're on the left or at the right, you are gone also. Because you will not use light. So imagine in a compound where everybody's light is connected in series. And then, inside my room, I decided to off my lights. Because I want to sleep. You want to read in your room. And because I off my lights, your light went off. You now be like, Uncle Prime, biko baile mo ka acho me gwa ogwo. Nsege, mwete ge ba nketa. Na mo achira hora that kind of thing. It will become fights. Are you with me now? It will become fights. And then on a day that I want to read, and you want to sleep, you will now off lights. And I'm just say, nebo because you nebo because you just 10 minutes biko. Okay? Or let's say I want to travel, because if I want to travel, I have to off everything in my house. If I off everything in my house, everybody will not have light until I come back. I mean, if you want to travel like this, you need to leave when when nobody knows. Maybe that time they take light, you just off everything and travel. Because if they see you leaving, I say, neighbor, where are you going? Nine may travel. E cross or get now. Okay. Good. So you say that will be the implication. That is why they are not connected in series. They are connected in what now? Parallel. Okay. Let's continue. 38. An object moves in a circular path of radius 0.5 meters. Of radius 0.5 meters with a speed of 1 meters per second. What is the angular velocity? Okay. They said radius of 0.5 and then velocity of 1 meter per second. So V is equal to omega R, right here. So omega is V over R, which is 1 over 0.5, which is how many? 2 radians per what? Seconds. Omomado. I pray that your exam will be as simple as this. See, the thing is just for you to don't fear. Do not be what? Afraid. Do not be afraid. Do not be afraid. Do not be afraid. Like when you are going that day, go with morale high. See, let me tell you one thing. If you know the person that is behind you, if you know the kind of God behind you, you know, as a kid, because you are still kids, everybody here, you are still kids, okay? As kids, you've probably not experienced the mighty power of God. Like it might still be doing you. Does he answer prayer? Does he not? But from my experience, you know I've lived for like 900 years. From my experience, I can tell you, like I can beat my chest and tell you that he answers what? Prayers. He answers prayers. Matthew 7:7 said, you should what? I don't understand. Which one is her? Hey, Jesus. I don't know why you take me for. I don't know why you take me for, but God cleans your heart in Jesus' name. Now, Matthew 7:7 said you should do what? Ask, and it shall be given. If you seek, you shall what? Find. And if you knock, the door will be what? Opened. The problem is that most of us are not even knocking. Are not knocking. If they ask you to pray now, your prayer point is, God, give my mother money. Give my father money. God, that my auntie that is sick, please help her. Let her get better. God, my cousin, you know she's married now. She needs children. Give her children. God, now only you get issue. Only you. See, the truth is that if I ask you now, let's say I ask you, what is the one thing that if you get now, you'll be very happy? Is it not admission? It is admission. So what you should be praying to God is that, God, give me that admission. Don't need to tell him about money. He knows that money will come. Because if he gives you, he cannot give you admission and not provide money that you will use and go to that school. Are you with me now? So there is no way he will give you admission. You cannot say, God, I need admission now, and you will not pass JAMB. Because God knows that it is JAMB that will even give you admission in the first place. So he will give you JAMB, give you the admission, and then, when you even get the admission, that day you got the admission, your father will be like, Egadero. You don't know that God has plans. I can tell you this because I have experienced it in like face to face. You know, all these things they say, you know, you've heard them people calling God God of 11th hour. See, before I used to hear people say it too. I never experienced it myself. I experienced it. Like I experienced it one-on-one. So the truth is that in your heart or in your mind now, you might be like you will not pass this JAMB. Like you have self-doubt in you that this JAMB, but don't be afraid. Don't be what? Don't be afraid. Because God is what? With you. God is with you. Don't be afraid. Don't be. All you need to do is continue telling him. Like continue telling him, God, if I fail this JAMB, now you fail him. Because they will laugh at me. They will laugh. You might say they will not laugh at you because you know normally some of you, I don't even know the kind of human being where you be. But if not for anything, your parents, your neighbors are watching. Not only your neighbors, people around are watching. You feel that they don't know they are going to lesson every day. They know you are going to lesson every day. They know. They know. But the fact that they don't say does not mean they don't know. They know you are going to lesson every day. When your mom, your dad goes to work, they ask them. They know you are going to lesson. They know you are going to lesson. So they are observing. They are observing. So go and tell God that if I fail this jam, you are the one that failed. Because people will laugh at me. People will laugh at me. If I stay at home 1 year again, people will laugh at me. I will laugh at my family. But many of us cannot make that kind of prayer. You cannot make that kind of prayer. Why? Because, you know, one thing about this generation is that I don't know the kind of spirits that possessed them. Gen Z. Gen Z. There is this spirit that, that possessed you people. Do I know? Generation Z now. Generation Z. What is Z? Zombie. Zombie. Yes. Okay? Cry. Like, tell God that you know that you have not. Like, you've not read. No, Megan, normal. I know he knows, but tell him. Tell him. Do you think the father that gave birth to you does not know you have needs? He knows you have needs, but there are certain things you still need to tell him. You still need to tell him. So you have to. He is your Father in heaven. Remember, in this case, in this war, because you have to see it as a war. In this war, it's either God is with you or your village people. You cannot be at the middle. Say, God is still like this, village people, I'm at the middle. You are either on God's side or village people's side. One of them must happen. So you have to go back. Like, today we're getting Monday. If it means you will do dry fasting. If it is dry fasting that will give you admission, will you not do it? You will do it. You will do it. Be genuine. Be genuine about it. Be genuine about it. Okay? It's not today that we start hearing miracle cases. Miracle happen year after year after year. Okay? I will tell you that God is not a magician, but I believe in miracles. Miracles can happen. Unimaginable favor. Unimaginable favor can come upon you. It can. Right on side. Okay? So please and please, in as much as this week you are doing your final preparation, don't keep God on one side. Are you with me now? Idobi on one side. Because Idobi on one side, do you know how many billions of people that are praying every day? And then you now decide to keep God one side. You're not getting a. Okay. Your last question. This is capacitors, parallel and in series. Class, when capacitors are in series, what do? You add. You just add. Abi? When they are in parallel, you just what? Add. Then when they are in series, you do 1 over B. 2 plus 2 plus 2, 6. So that means that 6 will be in series with 2 and 3. Are we here? Let's get our answer. 1 over C total equals 1 over 6 plus 1 over 2 plus 1 over 3. Are we here? What is the LCM here? 6. 6 into 6, 1. 2 into 2. Sorry, 2 into 6 is how many? 3. Plus 2. This is 6 over 6, which is what? Which is 1. So 1 over C total is equal to 1. So C total is still 1. Abi? Good. So how many did you get comfortably? 40 over 40, right? Now, is it you that got it or me? Okay, us, right? And so shall it be in exam in Jesus' name.